Okay, do you see my screen?
Yeah. Yeah.
Okay. Add you a bit of volume. So today, this week was all about like sorting, matrix, linked list, and the queue and stack. What we're gonna see today, they are the same, but same concept, just a bit different from each other, but they are the same topic. So in queue, in stack, by the way, if you don't have this calendar, you can add it. Go to like maybe welcome or announcements. You're gonna find it here. Click on it from desktop and add it to your calendar. So like stay with us in the flow. Next week we're gonna see tree, graph, heap, and tree. It's also gonna be fun week.
Sorry
Yes,
for
brother.
cutting you short. Based on
Yes.
based on the calendar you did mention now, I'm trying to add it to my own calendar, but I'm having issues as regard it was giving me the calendar link does not exist or something, so I don't know what's really happening.
Do you add it from the phone or from the desktop?
It seems I had it from the Discord.
Okay. Okay, you can, after this PLD, you can like share screen and try to help you add it. Is that good?
And no problem.
Okay. So, they jumped to so we did the first week, right? And we did the week 2. And just to remember, like the goal, like from this, from all this is like to motivate each other to solve this problem and do them. So like we all have all week, but everyone have other stuff, busy with life. So you might not be able to like attend the PLD or like do this problem code. But if you can like solve just one, at least just one of this essential question, that will be like at the end of 3 months you're gonna solve a lot of late code, and that's with time gonna be like with compound effect. You're gonna have a lot of problem that you're familiar, so your chance in the interview is gonna be more higher. And this PLD is also to like keep us motivated to going through these 3 months and solving more problems. So let's jump to queue and stack. The queue. The first, let's read about what is queue. Introduction. A queue is a linear collection of elements that are maintained in a sequence and can be modified by the addition of elements at one end of sequence in queue operation and the removal of element from the other end, dequeue operation. Usually the end of sequence at which elements are added is called the back, tail, or rear of the queue, and the end of at which elements are removed is called the head or front of the queue. As an abstract data type, queue can be implemented using array or single linked list. This behavior commonly called the FIFO, first in, first out. The name queue for this type of structure comes from the analogy to people lining up in real life to wait for goods or service. Breed's first search is commonly implemented using queue. Okay, what is this? Okay, so this is like a tree algorithm. Okay, searching a tree is commonly implemented using queue. Okay. Okay, time complexity. Thing to look out for during the interview. Most language don't have. First, let me keep the chat to the right so I can, if someone writes something, I can see it. Most languages don't have built-in queue class which can be used and candidates often use array, JavaScript or list Python. As queue, however, note that the dequeue operation, assuming the front of the queue is on the left, is such a scenario will be on because it requires shifting of over all other elements left by one. So if we are using array and the front was in the left, if we remove some element, we need to shift all the elements to the right, from the right one step to the left. In such case, you can flag this to the interviewer and say that you assume that there are a queue data structure to use, which has efficient dequeue operation. Corner case, empty queue, queue with one item, queue with 2 items. Okay, let's see the stack now. But before we do that, let me check queue. Queue image. This is like some queue image. FIFO. Which is queue is FIFO or LIFO? Yeah, FIFO, right? Okay, so this is a queue, FIFO. So you enter from here, and when you dequeue or you pop elements, you pop the first one that's enter. Like this one. So like it's like a waiting in a queue. So I push like, yes, someone will say something.
Yeah, you should in queue you should push in last queue and pop in first queue. Stack you will push in last and pop in last. You understand?
So in the queue, someone post a picture. So in the queue, you push the, let's say in the stack. In the stack is like last element that was pushed is the first element gonna pop out, right?
No, the stack last element push in last and pop in last.
So
the queue push on
do it
last
like
in-
this. So this is stack,
Yeah,
right?
push pop آخر حاجة دخلت last.
So
last.
if I push element and then I push another one,
Yes.
if I wanna pop the element, I'm gonna pop the last one.
Yes.
So it's like the last element that was pushed is like the first element I'm gonna pop off.
Yes.
But in the queue,
queue you will pop the first.
yeah. So you push elements, push elements, push elements. No, sorry.
No.
The push elements, then push elements, then push.
Horizontal line is better to represent a queue as if a line of people in a queue to get
Yeah,
something.
you're right. Wait, do it. So
And
like
that
we
one-
have queue like this. People come from here, they go out from here. So
Yeah.
first person, second person. So when I push elements, it go to the first, then I push other, it go to here. But when I pop, I don't pop this one. When I dequeue elements, I dequeue this one, the first one, right? It's like you are going to some service, you come first, you're gonna get served first. But when in stack, if you come first, it doesn't matter, right? Only the last one that's gonna be served first. But let's see a video about it. We'll make it more clear.
Welcome to academic.
Let me change screen. Please, if someone have question, feel free. You can open mic and talk. You can write in chat. don't let imposter syndrome take over you. We all here learn, no one know everything. Let me see. Change window. Okay. Okay, tell me if you can see the YouTube video. You can write in chat.
I can see it.
Okay, I'm gonna play.
Game
Let's go.
tutorials. In this video, we will look into the differences between LIFO and FIFO. Last in first out or LIFO is a method of accounting for valuing inventory. This method is based on the assumption that the last item placed in the inventory will be sold out first. That is, reverse chronological order will be followed in issuing inventory from the stores. Whereas, an asset management technique, in which the actual issue.
Okay, wait. We have input. We have 1, 2, 3. 1, 2, 3. Okay, and then if we are using FIFO, it's gonna be 1, 2, 3. But if we are using LIFO, it's gonna be 3, 2, 1. Okay. Then we have this push pop. Yes.
Start from the beginning of the video.
Okay. Can you repeat?
Yeah, just restart the video.
Okay.
Academic game tutorials. In this video, we will look into the differences between.
Yes, go ahead.
Please increase the volume so I can hear it loudly.
Volume.
Oh, it is the max. This is the max. I don't know how to increase this more.
You're gonna find the volume icon there in the bottom, and you're gonna increase it there, bro.
Oh, maybe in
guys.
the stream.
No, I don't talk about.
Are you using hand free?
Browser volume.
Are you
Let me
using
see.
hand free?
Uh,
Are you using hand free?
Android. What?
As in, are you using earpiece hand free with your laptop?
No, I am using desktop. This is Google Chrome.
What I'm saying is that your AirPods, did you use earpiece?
I use
or
like
hand-free?
earpiece. It's talking about the earpiece. If you
I
put
have
something in
headphone.
your
Yes, I have
ear,
headphone.
headphone. Yes. That's something.
Just remove it, and let's see.
And how I'm gonna hear the video or hear you?
Okay.
Guys,
there's
you have
no
like
speaker
in
here.
the right of the video, in the right of.
Okay,
you're
let's do
gonna
one
find,
thing. Let's do
guys,
one thing.
the
I'm gonna post the
LIFO
video
and
in the
FIFO.
chat,
Last in
and
Link
we're
in
gonna
the
call 1, 2, 3, and we're gonna play it together. What do you think?
Wait. There is a
Yes.
website like Watch Together. Let me share.
Yeah, that's also a good idea. Do you want me to share it, Absamad?
Me also, I can hear you well.
Yeah, this one. You can go there and
What
create
about the one
and
in
share.
the YouTube, like this one?
And when you pause, for example, everyone will pause for
What about this one in
everyone.
YouTube? You know, in Discord.
If there is any limits, so we're gonna check it. Okay.
Yeah, maybe there's limit.
If someone can't enter the activity, just say it in the comments.
Okay.
So everyone needs to ignore.
Okay. I guess everyone did enter.
Skip the ad.
So guys, everyone need to skip that.
Egyptian.
Okay, the ad is gonna be annoying. I guess this not gonna work. Let's do it very simply. Here's the link of the video. Open the video on your Chrome and wherever you want, and we're gonna call 1, 2, 3, and we play the video.
can skip this either. None.
Order, that is, it first item placed in the inventory will be sold out first. That is, reverse chronological order will be followed in issuing inventory from the stores. Whereas an
Okay, so 1, 2, 3, it's gonna jump here. Then we're gonna, if you wanna pop some element or bring some elements, we're gonna bring it from the last one.
asset management technique, in which the actual issue or sale of goods from the stores is made from the oldest lot on hand, is known as.
Okay, FIFO is a queue. Okay, so this is the difference. It's entered from the back, B, C, D, F, and then when we DQ from the beginning, so the first element that's entered.
As first in first out or FIFO, it follows a chronological order, that is, it first disposes of the item that is placed in the inventory first.
Okay, is this part clear to everyone? Because we're gonna jump to let's code. It's gonna be confusing between LIFO and FIFO. So if you have some question, it would be nice to say it now. Let me write this just to keep it in mind. Okay, everyone here understand FIFO and LIFO? Okay, we continue. What is next? Yes, someone said something? Let me put the chat to the... Okay, so we did read the queue, right? Let's read the stack. Stack, introduction. Stack is an abstract data type that supports operation push, insert new elements on the top of the stack, and pop, remove, and return the most recent added element, the element at the top of the stack. As an abstract data type, stack can be implemented using array or single list. This behavior is commonly called LIFO, last in, first out. The name stack for this type of structure comes from the analogy of a set of physical items stacked on top of each other. Stacks are an important way of supporting nested or recursive function call and is used to implement deep first search. Deep first search can be implemented using a recursion or a manual stack. Okay. Corner cases empty stack popping from an empty stack. Stack with one item, stack with two items. Okay, let's jump to queue. Let's see what's the problem. Essential question. We have this one. Let's see it. These documents have more explanation about queue stack and difference between them, and like tips and advice, like stuff to be aware during like a technical interview. I will share it in the chat if you wanna like check it later. We can check a quick example, for example, for queue. So we create a queue and I put 1 and then I put 2, like 1 and 2. So if I did like get element, which one I should get, 1 or 2? So here it gets 1 because in queue 1 is the first that entered the queue, and then 2 for stack. Okay, let me zoom. So here we create queue, right? And then the first person 1 enter. Is this better? And second person number 2 enter. Now if I wanna do get in queue, like DQ, the element that's gonna be is the first one that's entered the queue, so it's gonna be 1. And if I did get again, or like DQ or like pop, it's gonna be 2. And so this is the queue. for the stack is different. So imagine stack as array. The first person enter the stack, then 2 enter the stack. Let's say plate 1, plate 2. If I did pop, it's gonna get the element 2. If I did pop another time, it's gonna take the element 1. Okay, so let's read the problem. If someone have question, like please go ahead. Anyone? All clear? Okay, perfect. Now here's okay. I saw one picture here. I want to show it, but I forgot. Also, let me show this one.
Sorry,
Yes.
Wasif,
Yes.
what language was that? That was saying
this one
Python?
Python.
I think this
Yes.
is Python with
Oh, okay.
in
So if you wanted to remove, okay, that's pop, right? Yes.
Yeah.
Right.
So if you leave it empty like this, pop empty, it's gonna
Even this guy that they forget Python also.
wait. Can you repeat,
Okay.
please? Who is talking? Can you repeat? Okay, maybe he was talking with his family or something. Let's check. Wait, let's check first this image. So this is definition for queue. Operation, use cases. Okay, so this is the graph. Last element added, first element added. 1, 2, 3, 4, 5, 6. And this is the stack. First element added, last element added. Okay. Let's see. This one. Stack. Last element added. 1, 2, 3, 4, 5. Push operation. Push or add element 7. Add it to the top of the stack. Here, pop operation. Pop remove element 7. Okay, so if we were wait, is I'm streaming just okay, you guys can see it, nice.
Sorry, it's a terrible explanation, but essentially it's like a stack of plates, right? So if you want to add an element, you can only add it to the top of the stack. You have to visualize it in that manner, as the elements stack one on top of each other. So when you add an element, you add it to the very top of the list. And then when you pop it, you add, when you pop, you remove the first or the top of the stack, whatever element is at the top. If the stack isn't empty, of course, then you return that element that you popped from the list. From the stack, sorry.
Okay, so this is, but if it was queue, the pop gonna react different, right?
Absolutely.
It's gonna be
called DQ and on queue.
Yeah. So if we were in a queue, if we wanna get the first, or if you wanna get element, it's gonna take 1 because this is the one that enter first. But if you wanna stack, it's gonna get. So this is the main difference between stack and queue.
Yeah, it's just an orientation thing. You should just visualize them a little different, and they'll make perfect sense. But I think we're all familiar with stacks and queues, right? We've all been in the line. So.
Yes, remember. Okay, someone asked me about. So this is Python. This is pop. So let's do, for example, if I have a list of array. Let's say list equal 0, 1, 2, 3, and I did print and I did L pop, and then I print the list, run. So what's happened here is one of the element is like deleted or it gets pop, and the list becomes 0, 1, 2. So if we wanna see, is this behavior queue or stack? What do you think, guys?
I think this is the behavior of queue, because
I think it's a stack.
Okay, Shazer said queue.
Because okay, each add 0,
Wait.
add 1, add 2, add 3, then 4 is out. So the 3, the last to go in is the last to go out. So
Yeah.
is the first to go out. Sorry, so that's stack.
Stack.
This
Okay.
this will be
Is it clear, Shaza? Do you know what? Do you get it? Like, why not Q?
Yeah.
Okay, but what in the queue? What's the one? How it's gonna be? It's gonna be like this, right?
in Java. In JavaScript,
1, 2, 3.
all
If this pop was like a queue, it's gonna be 1, 2, 3, and we're gonna get like 0, right? Make sense? Okay. Did this one make sense? Like if it was a queue, then we're gonna pop like a 0, and it's gonna become like 1, 2, 3. So okay, let's continue. Where we were? Yeah. Yes, that's what should happen in queue. Okay. So this is the first problem we have, and it need a bit focus. Implement stack using queue. Okay, what do you mean by that? Implement stack using queue. Implement a last in first out LeFo stack using only 2 queue. The implemented stack should support all the function of normal stack: push, top, pop, and empty. Implement myStack class. Void push element x to the top of the stack. Then we have pop, remove the element on the top of the stack and return it. Then we have top, return the element on the top of the stack. Okay, let's do Excalibur with this so we can understand it well.
For top, it was returning the element without removing it, as far as I can remember.
Top, yeah. Remove the element of the, no, I think.
Return.
Yeah, return. This is remove.
Okay.
Pop gonna remove. Let's see this one. Stack. Okay, empty stack. We push element 1, push it again 2. When we pop, we start from. Okay, I believe now it's really clear. This is the stack. And this is the queue. 1, 2, 3, 4, 5, 7. In the queue, 1 was deleted. Okay. DQ. Okay. Okay, I may say pop for both of them, so I just bear with me. So implement stack using queue. So we're gonna implement stack using queue. Okay, let's see. Let's say this is the stack. I have A, B, C. If I implement a stack should behave like this: A, B, B, C, right? So the push is the same, but the queue, let's say, because we're gonna implement the stack, so let's say it like this. Wait, implement stack using the queue. So let's
but the pop is different. The pop the pop in stack will be C. The pop in queue will be A.
Yeah.
But two in push, like another.
Yeah, it's gonna be like the difference is the queue. So this is stack, right? And this is queue. Now if I put E, B, C, it's still the same. So if we're gonna implement stack using queue, the push gonna be the same, I guess, right? We just push it. But if we wanna do pop in the stack, this one that we're gonna remove. Pop this. In the queue, we're gonna pop this. So somehow we need to implement stack using queues. So this is the queues. This is the queue. But if I did pop right here, I should not get A. I should get C. So this way we implement stack behavior using the queues. Implement a last in, first out, LIFO stack using only 2 queues. So we can use only 2 queues or 1 queue. It depends what we wanna use.
I don't understand this queue. What
Which one, Mahmoud?
I don't understand this requirement, but using stack using queues.
Yeah. So
I think.
Okay, Shaza, your volume is very low.
Okay, I say, can we see input and output examples of the problem?
Yes. We can. Let's see. Are you recording, guys? Yes, it's recording. So. Yes, Mahmoud.
I think, but you شوف كلام my words right or no?
Okay.
Please come back above.
Yes.
Okay. I think stack with queue means when I push in the first stack and pop in the last stack. يعني when I push the first node, the first line, not the last line. Think if he say with stack مش with queue, I think it means push the last and pop the last. In this case, I think it means push the first and pop the last. You understand?
Yeah. So like our let's say this is our queue, right? This is our queue. Let's say it like this, queue. Let's say it like this, so it's become more easy, right? You with me, Mahmoud?
Yeah.
So we have A, we have B, and we have C.
Yeah.
We're gonna push A first, right here, right? And we're gonna push B right here. We're gonna push C right here. So this is normal behavior for queue or for stack. Both of them have the same. Do you agree?
Yeah, I think I know, but I don't understand why.
Wait.
What between stack using queue?
Wait. Give me a second. So this is normal behavior for both queue and stack, right?
I'm kind of confused here. Like, I don't know. Maybe it's the way you're explaining it. I don't know.
Okay, but I didn't finish, guys, my explanation. If you let me at least finish.
Yeah.
Okay, so I'm asking if this part of pushing is the same for queue and stack. Like, everyone agree on this? It's the same, right? Nothing changed.
That's what I'm saying. I'm confused about
the push.
Yeah.
Okay, so let's say in stack, when you push EBC, you're gonna put it here, E, B, C. Like, isn't this the same as Q and stack? They're the same, right? Do you see it? Hello, Pascal?
Yeah, I kind of see it, but in the reality, the way it operates is not the same. That's my confusion.
Okay, let's see the reality.
Like, because if you want to push the first one, stack them like that. Yeah, I don't know.
Okay.
Yeah, like,
let's see example from reality. Let's say I have a plate box, and I have a plate called A. Right? I put it here. A. Then I bring plate B. I put it here. B, and I put plate C, it's gonna be here C. Like it will never be like C, B, A, right? Because I push A first. If you push A first, it's gonna always be in the bottom, right? Is that clear? In the queue also, it's if you push A in the first, it's gonna be always in the front, and C in the back.
Okay, no problem. It's fine. Yeah, it's fine.
You know what you get is because if we didn't understand this well, it's gonna be hard later to understand the problem.
No, I get your method. It's okay. I get your method.
Okay, anyone else have confusion here?
Yeah, it's still confusing. Oh, maybe I should explain how the level in which I've understand it. I understand that the first in
Yes.
is a, and for the stack also the first in is a. But when you are dealing with the I mean the last in, when you are dealing with the first out and the last out, that's what I'm getting issues on. So
We're dealing
I
with
understand.
first out. So first out, what does that mean? It means stack, right? Stack. First out is stack and FIFO is queue.
No, first in first out is queue.
LIFO is a stack, not queue. So
LIFO is stack, yes.
Yes.
So the way the analogy you are using here is kind of still confusing. That's why, but I don't know if you can still buttress much on it.
Okay, is this image clear?
Let me check. Push. Okay. The image is cleared. Yeah, we're having the first in is push.
Yeah.
Is the first in is 1, and the first out will be the last. It will be the last item, which is 2.
Yeah. Now imagine this is 1, or like imagine this is A. This is A. This is B. This is C, D, A, F. Right? Now this is A. This is A. This is B. This is B. And this is A. Now notice something. When we push, just focus on just pushing now, don't focus on pop. When we push, is it the same or not? It is the same. Like if we push A, it's always gonna be here, A. And if we push A, it's always gonna be here. In both, in stack and queue, when you push, it's always gonna be here, like at the end. Or like the behavior of pushing is the same.
That's correct. It's true. Insertion is at the same position. Yeah, you're right.
So if we separate this, like if we understand this part, it's gonna make the problem solving much easier. Because when you're gonna pop, that's when the confusing part, or that's when there's big difference. Because here, when I'm gonna call a pop or pop on this one, it's gonna tell me B. But if I did a pop on this one or DQ, it's gonna give me A. Is it a bit more clear, Aridwanullahi?
Yeah, it's clear.
Okay. Anyone have question? Like everyone can see this?
Then the next one. Yeah, then the next question, the question is like, how do you
I will ask you for a second. Can you repeat?
I said, how do you build a stack using 2 queues? I think that's the question.
Okay, we're gonna go step by step. First, we understand push. Okay, that's good. Now we understand how push should work. Let's see if we're gonna need 2 stack, or maybe we can do it in only 1 stack, or maybe we can do it without stack. Who knows? Let's see. Let me go back to Skydrown. I posted the screenshot there.
I was talking about the
Yes, Mahmoud.
I was talking about the requirements, not the step and the queue. The
Okay.
requirement is done. That I
Requirement.
solved this problem, but the requirement until now I don't understand why. What the two queues using only two queues
Okay.
using queues.
Okay. So this is Q. Q first one, Q second one. This is Q.
This is my passport.
So for example, this is Q. So if I put something here, it's gonna go here. If I put something else, it's gonna go here. Like you can use you can do Q with array, but I think in Python there's something else that you can use Q. I read it somewhere here. Where is it? Where are you? This one. Not that's the DQ. Sorry for this. Give me a second.
Why can't we use list in Python?
Yeah, we can use a list, but Python have one thing that is like a queue. I'm not sure where I did read it. Let me read this one. Most languages don't have built-in queue. Yeah, Dick with this one. This one. Where did I read it? I don't know. So Dick one. Python.
In Python.
Yeah, I saw where you were using that queue to like. That's why I asked you what language was that. I don't know where you saw that.
So you create DQ. So it is like a list. I think it have just some function that's already built in, like append left, pop left.
I think
You
that
can use
class. It has yes, pop left.
Pop left, yeah. So
recently, yes.
Yeah, so it can make it. So for example, if you want to do pop left with just pop right here, if I want to pop 0 right here, if I want to pop 0, I need to do 0 here, right?
But you have to initiate collection the queue. I mean, you have to import the function collection the queue first before you can able to use it.
So yeah, imports.
Yes.
Imports collection. Can we do like import collection from TQ or something?
I think now I understand this requirement for language like Python. You can use two queue key, but we can use one queue in Python using class. You can declare class, and in this class we can declare variables next and the previous and the value, and we can in another class create object in this class, and every object point to another object. This will be and we can declare two variable, the first and the tail in the class. You understand?
So like we're gonna do it with the classes?
Yeah,
like
we can.
I think here the like okay, let's see here because we didn't see this one. So first they call myStack and they create a new this class myStack, and then they push one, right? So using this push, this is what we need to create. We need to create method push and pop and top, right? And init. And then we did push 2. And then when they did top, what it does, to return the elements on top of the stack. And how many elements we push? We push 1 and 2. So if we go back quickly to Xcalendar, where is so this is our queue, right? We push 1 and we push again 2, right? This is Q. If I did top, right, in Q behavior, it's gonna return this one, right? In Q behavior, it's gonna return this one. But because we are doing implementing stack using Q, so it should return this, the last element, like stack, like the normal stack. So that's why here it returned 2. Right, and then if we did pop, then it's gonna remove this one. It's gonna return this one too, because top it just show what is the element without remove it, but pop it's gonna remove it. So if I check if this empty, or like if I check if I print this, it's gonna show only one. Then it's did empty return, it's returned false because there's still one here. Let's read it again. Implement last in, first out, LIFO stack using only 2Q. So in 2Q we can use this. This is a Q. You can use Q in Python with this. I never used it before.
I have idea better than this. The class, like I say, you can implement the class above this class. Implement the class. We can use node linked list in this Python already. You can use the class above this class with the node. In the node, there is value and the next, and we can use the previous. Okay, in this class we can implement. We can declare variable to the head. Okay, and the variable to this will be stack. No, the head. Just the head, and if you want to pop, the head will be the back to the link in the node, the node before النود اللي قبلها, and you can free the next node. I don't understand.
Yeah. So this is using linked list.
Yes.
Okay, but I think the way they are, like we're using DQ or like list, it's much simpler. Like you will need only one line for each method, because you're gonna queue, add, append, pop. Like it's gonna be more simpler if we use like queue like this.
Okay.
I think so. But we can try do them both and then compare them. So first, let's make sure everyone understands the problem, right? Let's read this one more time. Everyone focus, and then we try to see if, okay, I understand what they're asking from me or not. So implement stack using Q. Okay, what this mean? Like implement stack using Q. So what they mean is using queues, which is, this is Q, right? Like this Q. For example, this is Q using this one, this function. Using this Q, I'm gonna implement stack behavior. What that mean? That mean the way I'm gonna pop this Q, it's not gonna give me the first element, it's give me the last element. And the way I'm gonna push, it's not gonna push like Q, it's gonna push like stack, but because the stack and push have the same behavior and push, it's not gonna matter. So using only 2Q, the implement stack should support all the function of normal stack: push, top, pop, and empty. So implements the my stack class, void push element. Okay, let's see. I think we understand it, how the stack and the queue behave. Anyone have question, like confused about like how stack behave or queue behave, or how we can do this one?
if you use the C language, it will better to understand very well and speed. It was I think it was 0 millisecond with me. I
Yeah,
don't
yeah, but like I am really bad in C, so I forget everything in C. So only Python in my mind right now.
If you use C, the length of code will be very long. It will be
That's
very
true.
long.
Yeah, like in Python, it's gonna be more shorter, but the goal here is not to code it. The goal is to understand it, and I think now we understand it. Now you can code it with any language. So Shaza said what this mean right here.
The C will be large
So
code, but
This is the first input.
okay, so this input right here is like explanation for this. So first, we're gonna call my stack, new my stack right here, right? Is this gonna return something? No, it's not gonna return anything. Or like, did we give it like arguments? No, it's empty right here. It doesn't have any arguments, this my stack. Now we're gonna call push, okay, method push right here. Did we give it arguments? Yes. What is that argument? Is 1. So this way is like we can easily test our stack. When we, for example, create a new case, we can put the arguments in here, right? So this method take those arguments. Now the second one here, push again, but this time we're gonna push with argument 2, right? Right here, 2. Now I'm gonna call top method. I don't need this method, like doesn't take any arguments, but it does return something. Notice this one return null, because this one doesn't return anything, right? But top should return 2. And if I did pop again, it should return 2. If I call empty, it should say false because I'm still have 1 in the queue. Is this clear, Shaza?
Yes, so clear. Thank you.
Okay, so now, by the way, Mahmoud did post C solution for this. So like, guys, feel free to check it out. Let's take like a quick look on it. Oh God. Okay, let me out, please. Oh my God. What? 100 line? Oh God. Okay, I'm sorry, bro.
look,
I'm joking, bro. Like, good job for doing this. Like, this is a very hard thing.
The first struct I created this for me.
Yeah.
The second struct and all the function.
Yeah. So you did use a like. So this is make me remember trauma of this project in Alex.
You can now change Python to C to look what C give me وانا هزودت ايه من عندي يعني what C give me and what I change.
I didn't understand you, Will Mahmoud. You can speak Arabic and I will translate.
اوكي ممكن تغير البايثون دي عشان تشوف هي ادتني functions ايه وايه وايه وانا زودت ايه من عندي. انا زودت
okay. So you wanna tell me is like change here C so you can see how many stuff. Okay, it's so long. Yeah, there's too many stuff.
زودت استراكت من عندي عشان اعملها بطريقه معينه واقلل البرفورمانس بتاعتها وزودت فانكشن استخدمها بس جوه الكود.
Okay, now let's so we win some time. We already 1 hour. Let's try to solve this quickly. Let's see simple. They say we can use 2Q, right? Right. So let's do a Excalibur.
Yes, something.
Can you repeat? Can you repeat that?
I said I want to say something. Can you go back to the lit code?
Yes.
I want to show you. I think I observed something. Scroll down. Sorry, yeah, scroll down.
Okay.
PLD, yeah. We have example 1. Yeah, if you notice that we have 2 lists there. Where we have push, top. So I think, and the second one is an array of arrays, right? So I think what they want us to use these 2 inputs as though they were queued, and then use them to return a stack, which is the output which you have down here. So now, for example, we'll be using this my stack. We'll pop my stack from the front, and we'll pop the first lists in this array, the second array you get, and we use those two to then decide what is going to return. Like we'll create an array and then return what we need to return from that stack. Yeah, I think that is what they want us to actually do.
Okay, so we're not gonna use this. This is not the program input. This is just for test cases. Like if you see here, they say your my stack object will be instantiated and called as such. First, they're gonna call my stack object, right? It is the same here, right here. Because now if I wanna create like a test case, new test case, I'm gonna call my stack object, I'm gonna call method push. Do I give it argument? Yes. What? I give it 10. I'm gonna push number 10. So this to input is just to create test case, because it's gonna be hard to test this class. So
yeah, I get that.
yeah.
What I said, these two inputs now are going to be in form of queue.
Yeah, these two here. Yes.
So we'll be popping from the front, from the first input will be the first one to come out. Then in the one we'll be creating, like the stack, we'll now implement the stack using these two inputs that we have.
So this one we're creating is the stack. This is not the queue. It's gonna, so it's queue, but it's gonna work like a stack. So like it depends on the code that we're gonna write here, is what's gonna make it behave like a stack. Even right here, we're gonna use this, a queue, DQ. We're not gonna use like a list. At least that's what I understand. So let's jump to it. Maybe in the code it's gonna be more clear. Let's see. So how to import this stack? We're gonna import case from here. Import collection TQ. So I guess we can do import TQ from, I think. Can we do that? And then first stack. Let's create first stack right here. They said what they said, like two stack, right? Stack using only two queue. Okay. So this is our first queue. And maybe we don't need any second queue. Maybe we need second queue. Or like because it's gonna be like a stack, let's put it like a stack, and we know it's not a stack, it's a queue, right? So let's create it here.
I think it means you can when you can تفضي empty the stack in another queue and pub first. I will see.
Yeah. So I did understand just a bit. Can you repeat that? Yeah, can you repeat?
I think اللي فهمته انك تعمل بوش، هتحط في كيو، لما تيجي تعمل بوب هتفضي هتبقى كيو كده، هتفضي الكيو اللي طلعت في الكيو الفاضية وتاخد من اللي على الوش ولا ايه كده، هتبقى كيو اصلا مش هتبقى
Okay, you're saying is we're gonna push in the queue, then we're gonna like pop and then push to this one. I actually don't know how we're gonna do it. Like we are brainstorming together. So they say stack using only two queue. Let's say
understand what's using two queue.
like this one. This is first queue, this is second queue. But maybe we can do it just with one queue.
how we can use two queues in this problem? How we can...
I'm thinking Mahmoud is meaning like in a queue you're first in, first out. So if you want to reach the last element, you empty the queue, all the other element in the queue, you put them in the second queue, and you are left with only one element.
Okay,
so
that's a good
this
idea.
element in the stack. I'm just like the idea here.
So if we have A, B, so if we put here A, let's say this is our main stack or queue. Yeah, stack. This is main stack, right? And we put B, then we put C. If I did pop, it should return what? It should return C, right? Because I'm implementing stack, but I'm using Q.
Yeah, you can empty queue.
Yeah, you are using queue, so when you pop from when you remove an element from a queue, you will get the C.
Yeah, so we can put here C,
yes.
and
no,
then
you can't
B.
put this in the other stack.
Yes.
You can't put C or B because it's a queue. You will go from down, from the very first element.
Oh yes, like from.
So you put A in the other queue. It's the first element in the other queue. You maintain its order. Then you get B in the second queue. You maintain its order. You only left with one element. It's the last element in the queue.
Okay, and then that is okay. So I'm gonna see the length of this stack, and I'm gonna keep popping all of them here.
I think
think about it like a circle, yeah, a rotation of a sort, where you keep pushing and popping them until the last one is at the front of one of the queues. Essentially, you're just rotating them to make sure that how to say, if you had an order 1, 2, 3, 4, 5, let's say 1, 2, 2, 5, right, in one queue, you'd make sure that as you push in the elements into the one queue, you pop them out and then you put them into the second queue, and then you do that until the last element that was added is at the front of either one of the queues.
This one.
Essentially, it's like a circle. You're just making sure.
Okay,
you're
that
just
makes sense.
rotating it until it's still the front. Yeah.
So in this case, if I pop, I'm gonna get C. So that's exactly the stack behavior, but I'm using 2Q. So
Absolutely.
that's crazy. They do it. Please, if someone have question, we did maybe go fast on this part. Just ask. And we see we can repeat explanation.
It's a little difficult to visualize, but I'll try and find an example.
Maybe we can do it like this. Okay, so this is 2Q. Let's say like this, 2Q. And we have this right here.
Question.
Can you repeat?
I want to ask a question.
Yes, go ahead, please.
Okay. So I think I want to just get how do I call it? A better view of what the 2Q is. So what you are saying is, say for example, we have a queue that has, we are going to input like, okay, let's say 4 elements to it. So we are going to have 2 queues of the same length, something like that, or 2 queues of the same length. Then when you put in, let's say for example, 1, 2, 3, 4,
1,
for it to work
2,
like a stack.
3, 4, right?
Yes, so for it to work like a stack, 1 has to go to the second queue, 2 go to the next queue, then 3 to the next queue.
Wait. What do you mean by second queue? We are using 1 queue here.
We're trying to implement a stack with 2 queues.
Oh, okay.
So what we have is first in, first out, irregardless. So there are 2 first in, first out. So what they're explaining is, so for first in, first out, we do it on last is the one that is first out for the first queue.
Yeah, so 1. This is normal queue behavior.
That makes sense.
If I did pop, it's gonna get 1. This is in queue, not in stack. But in our case, we wanna when we do pop or we do queue, we need to get 4. But
Yes.
but it's not gonna work. We don't have this ability, right? In queue. So one of the solution that Mahmoud Manzella that suggests is like, why not when we wanna gonna do pop to get this one, right? Because pop in queue, it's always gonna get this element, right? It go to the first one, it take it. So before we're gonna do this pop, we're gonna empty this all right here, and then we're gonna do pop, not all. We're gonna list last one. So we know the length of this, right? We know the length of this. So we can empty just this part. We're gonna take it right like here. 1. Okay, 2 come here. 3, 4. Again, we're gonna loop again. Take this one right here. Again. We're gonna take this one right here. Again. Okay, we have last element. We know it is the last. We're gonna show it. Pop.
Check the length of
And
the
then-
queue. If it's only one element left, then we know it's the last element, and we don't need to put it again in another queue, because now we know all the elements. We have one empty queue and one queue with elements in it. So we check the length of the element and work with whatever queue has element in it.
Yeah, we can do that too. That's also a good idea. So that's gonna save us time. Like what she said, like next time we're gonna do a pop operation. We're not gonna come to this one because this one is empty. We're gonna jump to this one. So we're gonna like do a check to check if this empty or not. We're gonna do here.
So you are switching between the queues.
Yeah,
and moving
that's
them
very
until
smart.
Last element is the first element. Okay.
Yeah. Now if we're gonna do pop again, what's gonna happen? It should give us 3, right? Because we are looking for pop on stack. So we're gonna take this one here, take this one here, and because this is last one in the queue, we're gonna pop it again. This is gonna work again 2, and it's gonna keep going like this. I think this is gonna work. Now how to code it is the big question. Let's do it together. Yes, Mahmoud.
In JavaScript, we have pop and push. We have shift and unshift. To use queue and in array, to use queue and stack. Is there functions built in Python like this?
Yeah, there is pop. There is pop. مش pop. There is pop and append and
we can use one array as stack and queue in the same time.
No,
if you want to.
Yeah, but like I think there is a difference between array and DQ, like this function.
Yeah, if there is this function in Python, we can use this. Instead, declare instead DQ.
Yeah, I think DQ is better. I need to do more research, but I read it here somewhere, DQ, but I can't find it.
I don't know what DQ. I don't know. But in Java, if you use in JavaScript, you can use one array.
Q, yeah, this one right here. I think this one. Q.
In JavaScript concept, if you want to use a stack, you can do element dot pop. If you want to queue in first array, you can use unshift or shift. I think shift to insert unshift to pop in first. Or relax or in JavaScript. I don't know there is function
in Python. I don't know to be honest.
Yeah.
Okay, so because we solved them in Python, I guess we could continue with Python. So let's learn also together what is this queue work. So this is gonna be like a good opportunity for us to learn it. So DQ this is how you implement a DQ. So you create DQ. Okay, it have append function. It have append left. Do we wanna use append that's gonna put to the right, or we wanna append the left? Which one wanna append? Here. If we go back to our, when we're appending, are we appending to the right or the left? To the right, right? Oh, no, to the left. This one?
We are appending to the left. We are using the normal appending.
Okay, so
append it
to the right.
Last slide.
Wait, let me.
To use left, that means it will append it to the first in. I mean the front side. If you use append left, you understand. But if you use append, it will append it to the rear side.
Okay, so this is left, this is right. So if I append something, it's gonna add it here
to the front.
To the front.
To the front, yeah. Yes.
But the other one is gonna append it from here, the left.
Yes.
So the direction is what they mean by left. So this is going left, this is going right. So when they said append left, it doesn't mean the left of the queue, but the direction. So we don't wanna append it like this. So we're gonna use the normal append. Is it clear, guys, or I did go fast? Okay, so this is the queue, this is left, this is right. Or like this is front, this is back. When someone enter this queue, he come always from this direction and he wait here, right? Someone else come here. Now, the direction of appending here, what is it? So we need to see the arrow. It's going like this. Which going to right. Which means we're gonna use this append. Now, in Excel, like here, we said we're gonna append, let's say, stack 1. We're gonna use stack 1.
I think.
Yes, go ahead, please.
More clearer. Maybe we should be making it our push or queue. We should be making it in form of, we have to make it in form of the array. We have to make it in form of front and rear. Because this append, if someone doesn't understand this append, the way this append function works, they understand it may utilize the other append left. So in our analogy, I mean on a whiteboard, we should always specify which one is the front and which one is the rear. It's just a suggestion.
Okay, so this one is the front. And this is direction of right. So this is normal append. Right?
Yeah, yes.
Okay, so I guess we're gonna use this one. So append for, in our case here, what we're gonna append, X. So we have 2 stack, right? As we did here, 2 stack, and we append X. Now, here's the one that was tricky, the pop. Now, when we said pop, let me remove this so we can clear. Okay, 3. So we did append like 1, 2, 3. Now I'm gonna do pop and it should give me what? 3. Now if I did pop, it's gonna do 1. Let's do it and see. Let's see what's gonna show. Where is pop? I think it's gonna also be pop. Okay, here is. This function used to delete arguments from the right and of the DQ. Pop. Stuck.
Pop.
So this one not gonna work like this. We need to put this element all right here and then like we did before. So we're gonna see if stack 1 is empty. If stack 1, then we're gonna pop from stack 1, right? Stack 1 pop, but else that mean so we need to switch between these two. If stack 1 is not empty, do this.
It's
else,
not about it's not like this. I think you have to maintain like which stack you're doing, because you will check if the stack has more than one element. Because if it had more than one element, you will return the last element. But you will start before you, if the stack is to know which one is empty, so you can work with the other one. I'm thinking just.
So
yeah, I'm also thinking something like that. Menatala, sorry.
So this the first stack and second, they will never be both have something, right? One of them always gonna be empty, right?
Yes, one of them will always gonna be empty, but you can use a while after you check if it's empty or not. So if stack 1 is empty, while if stack 1 is not empty, while stack 1 len of stack 1, let's say bigger than 1, do this. And the same in the last and after the while loop ended, because you're only left with 1, you can return the left pop, and the same exact same with the other stack. Just idea here.
Okay, you did go fast a bit. Can you like split it to parts?
Sorry, Musib, is there a way to target that particular element and take it off?
In the queue, I don't think there is.
Without building another, what's the
I don't.
The pop don't the pop take an argument, or is it just?
It does take arguments, I think.
There is
Yeah,
pop in
pop can take an
Python.
argument, but we are not using argument with it.
Yeah, but
I think what we are, the Musib.
Yes.
The way I understand this is that, can you just go to the whiteboard?
Yes.
Just go to the whiteboard. Now, the way I understand the concept we are trying to derive is that we need the last based on LIFO. We are using Q. So now we have to use Q for another array entirely, for another structure entirely. That means we append 1 first, and we append 2, so it will now remain 3. Abi?
Yeah,
so
we're gonna put this all.
Situation, in that sort of situation, let's say we use this our empty array as stack 2. Let's name it stack 2.
Okay, at this stack 2. Stack 1.
So now in this stack 2, what we are supposed to use is that we are using top. I mean, for the stack, we are using top. So under that top function, we will use pop left. Stack 1 pop left.
Okay, so
stack 1 pop left.
So when I'm gonna call pop, it's gonna do pop left here.
That pop left now, it will now take 1. It will take 1. It will take 1 and return it inside stack 2.
Okay, wait. Pop left, what's gonna take? It's gonna take 1.
It will take 1 and return it inside stack 2. It will return.
Pop left.
Do you understand?
So
so
okay.
We have to write our codes in a sense that when the pop left is checking, it has to remain what's it called? The stack 1 must not be null. Stack 1 must not be null.
Can you open this?
So while you are popping, elements must be there.
Okay.
Yes, one element must be there. I hope you understand the concept. So that's how I understand it. I don't know if it makes sense.
Okay, I think I think
That's
I
almost
did
like what they were
understand it.
saying before, but it's also a nice concept. Yeah, nice.
Okay.
Can you
Yes.
open this link? Can you open this link, please?
Okay, what? Give me a second. Let me just check this. What already said about like difference between pop and pop lifts.
My name is Arid. No, it's not Aridio. My name is Ridwan.
Ridwan. Okay. Sorry, it was hard to read. Ridwan, nice to meet you. Okay, wait. Let me.
Can we practice? Yeah, let's practice it better.
Yeah, I just want to see how this pop and pop lifts work first. But
Amun,
yes, Mahmoud.
You can use just list, and you can use pub, and if you want to stack, and use pub 0 if you want to queue.
Yeah, but we want to use DQ like this one.
Without DQ. You want to use DQ?
Yeah, like we wanna like for this we wanna solve it with DQ function. So like we wanna learn how it work, like what our method it have. You know what I mean?
You want to learn what the DQ
DQ, yeah. So we نريد أن نتعلم DQ.
Yeah, okay. There is pop left. There is.
Yeah, so there is pop left here and there is pop, right?
Yes.
So this is our queue. If we did run here, it said DQ 6 1 2 3. Where is it? DQ. So 6 1 2 3 4, right here. But when I did pop, normal pop, it's give me 6 1 2 3 4. So it's pop from the right. If I did pop left, it do 6. Wait, it removed them both? Oh, because we removed it in the... Sorry, yeah, it's because we removed from it. So it removed 6. So in our case here, we can use pop left. It's gonna remove this.
If you want to queue, you can use pop left. If you want to pop stack, in this case, you can use pop, just pop. I think.
Okay, let's try it.
Yes. Pop will be stack. Pop left will be.
Remove from the left. Okay, let's try it. So in here, wait. In that case, we don't need actually to queue, right? Because we have pop left. It removes it from this side. Okay.
Exactly. That's
okay,
what
we
I'm
don't
saying.
need to queue. So this is actually make it more easy for us.
Yes.
Okay, so
just stack, not stack one, but
yeah, let's do stack.
Yeah.
It's gonna be still the same, right? Append X. But in here, we're gonna loop.
Is there a function to check?
Just left.
So what we're gonna do, like stack pop? No, I think we did self. Yeah, I need to add self here. Self stack pop left.
I think Monsef, if you use pop or pop left, you can show what the output. If there is value, it return it has value.
It will return it, right?
Yeah.
Because we have it
but
here.
You need to check.
If the stack
I thought you need.
Print.
Yeah, you need to check.
Yes. If the stack empty, I think it will be it will return سالب واحد -1. لا, no.
Oh, okay. We can try it here. Let's do it like this, right? And then we see pop left. What's gonna do?
Okay.
If it was empty, then so we can add a check, right? If the length of, if I did FDQ or like FD. Sorry guys, need to zoom.
Like if the length of the queue is at least more than 0.
Yeah. Or if I did this, FD. FD, I think it also mean that when it is empty, it is false.
Yeah.
So we can do this. So that mean here, before we pop, we need to do if self stack, right? Because if it was empty, it's gonna give us error. But I still something here not adding up.
self stack بتساوي equal equal stack.
Someone said something, please go ahead.
Yeah, the DQ
Yes.
is a module in Python that has the concept of double queue working as stack. So you can do a queue and you can do a stack with this DQ as it is. So you can actually pop from the front and pop from the back.
Oh, okay.
So
yeah.
you can do it
So
both
you can
ways.
append
So
from
it's
the left,
already-
append from. Okay.
Yeah.
Because this is new to me. I never. That's why I want to solve it with using this, so we can like learn both of them. Okay, it have count, it have remove. So, but is this make sense? Like I think it makes sense. We're gonna remove from the left, we're gonna return it, then it's gonna return 3.
But there is
basically stack now.
mistake. There is mistake in function top.
Top.
You can first use self dot save the variable in save the return function in the variable and check in this variable it has value or no. The return this value if has value. It's
Okay, so Mahmoud, so top is we're gonna see which element? This one, 3. It should return 3, right?
yes, if returned المفروض return 3 else المفروض return false مثلا.
Okay, so someone said should 2Q, but I don't think they force us, right? They said using only 2Q. But I mean, if you use 1Q, that mean it's better, right?
Yes.
So I feel like if someone said like, hey, use only 2Q, and then you said, you know what, I'm gonna use only 1. I mean, that is improvement, not something bad, right? But we did solve it with 2Q. Like we did understand the concept of like moving all this to here and then move it back, or like use this. So when we find out about pop left, it's become much easier. We don't need to move them here.
I don't understand what
That's the thing. The thing is it allowed? This is not ALX.
I mean, we're gonna see if it's accepted.
Acceptable, yeah. All those
Yeah.
pop left, all those append left and stuff. All right, no problem.
Most of the time, they are just going to take your output. They are not going to check what you do. How you
That's
did it. It doesn't matter to them. So you are just going to give them the answer. So
I see. You're right. You're right. You're right.
Based on what you are doing is like, okay, I already have the queues ready, and I'm just using the.
Okay, so what you guys, you wanna solve it with 2Q? We can do that. Do we go with the 2Q?
So let's use the faster method. Let's use the faster method.
What is pasta method?
I think we should follow the instruction. They want us to actually practice how to use Q.
Okay, we can. Okay, let's go use Q. So we have stack 1, and it's gonna be what? Let's call it DQ, and stack 2. Call it DQ. So append, we said gonna stay the same. We call it what?
In this case, why are we using DQ? We are going to be using 2 Qs. Because it just is like you are using 4 Qs now.
Yeah, Q and Q, right?
You have a queue that can remove from front and remove from the back, and then you are using 2 of it.
No. Like because they say only 2Q, so we were like, okay, let's do it with 2Q.
Okay.
So we wanna solve it with 2Q. So if we're gonna solve it with 2Q, that means we're not gonna use this, right? Is that right?
If we use that, we're only using 1Q then.
Yeah. So now we let decide: do we use 1Q or do you want to use 2Q?
Why 2Q? Why
Let's
2?
use 2Q to learn
Why
how to learn in this particular code. They
Can you
actually
repeat?
want us to implement like, okay, this is what they actually want us to do. Let's say we have Q1 and Q2, right? Now they want us to use 2Qs at the same time to solve a stack problem. Take for example, you want to pop from a queue. In a stack, when you pop the last elements that you entered. So in order for you to be able to implement it in your queue, what you do is you copy all elements before the last element to that queue, and then you return that last element as return. By doing
Okay.
so, you have already
Yeah.
using 2
So
queues.
so that's what we did before, right? Okay,
We're
let's
going
do
back
that.
to the first method. Yeah.
Yeah. So let's lose more time. Let's use 2Q. Okay. So in the push, we're gonna push to save stack. We can go back to this and fix it later. Let's say this is our main stack, because we need, I think if we do it this way, so it become easy at start, then we can edit the code after. So let's say this is the main, we can append. Now we wanna pop, we need to show this one, right? So our solution that was like, let's see the length of this. It is 3, so we're gonna keep moving this to this queue, again to this queue. It's gonna have 2, then the last element 3 gonna be here, and we're gonna pop it. Let's just focus on this one, how we can move this element to this queue. First, we don't want to move them all, right?
You can say stack2
So
dot append, then inside the square stack2 dot pop. So this way you getting the result of the pop and append it directly into the other.
But first you can save the output for of because if there is no element, it will be I think error.
Okay.
The first thing you do is an if statement above, at which you just like if the stack have element inside.
Okay.
Then
Let's.
inside you have a while statement, a while loop.
Yes.
While the length of the queue is bigger than 1.
Okay, so let's not go to that phase yet. Let's imagine this is our main stack. Okay, this is just secondary, and we already pushed 3 elements here, right? 1, 2, 3. Now what we want, like we want to write code that's gonna move this element to the secondary queue.
If you every time you use the length, it will be make time more time. You can use pop and push, and you can check if result or no, if there is return or no. There is save the time. يعني if كأنك use the value equal stack dot pop, okay, and after use if value has if value variable has
If you are
value.
worried about time, Munsif, Mahmoud, you can just at the top you can check the length and you have it in count. Let's say a counter, and then in the while loop you decrease the counter until it reach 1. When it reach 1, you have you only have 1 element left.
I can talk to Arabic please in just this point.
Yes.
ممكن تستخدم يا محمود دلوقتي تحط في الاول كاونتر فوق خالص.
لا بصي،
تحط فيه اللينس
تستخدمي
اول مره بس في الاف
لا
كونديشن.
ممكن، ما هو كل مره هيشوف اللينس بتاع دي وبعد كده يشوف اللينس بتاع دي.
مش هتحتاج
Musib, let's go with what the lady is saying. Makes
counter
sense.
variable counter at which you have the lens inside, you count it, and in the while loop decrement the counter every time you go until the counter only has one element left. When it has one element left, you only have one element left, and you pop it to the other stack.
Okay, I am guys have no idea what you guys talking about. But I am also confused. Like, can you just focus with me for a second? We have elements in this queue. We want to transfer them to here, right? What the problem? Right?
So what she's trying to say is that use a while loop, and then your condition is that when there is only one element in this queue, stop.
Okay, so while.
So you keep
while stuck right here. Length of
before the while
length of stack
if you have
greater than one.
If first before the while loop.
Okay, if what?
If there is an element, so if stack one.
Okay, if stack one.
Just can I say just
yes go ahead.
بص اقصد ان انت ممكن فوق الوايل تعمل بوب الاول، وبعد ما تعمل بوب تشوف هي رجعت فاليو ولا ما رجعتش. مش عارف البوب لو ما رجعتش بترجع فولس ولا ايه. فلو رجعت فولس ما تعملش حاجه، لو رجعت فاليو تعمل الفاليو دي بقى شوف هتعمل بيها ايه.
Okay, let's say something clear. Okay, this problem have like many way to solve it, right? So let's go with one way to not, because Mantilla gonna say a way, I'm gonna say a way, someone gonna say a way. All the ways are correct, right? But we need only one way so we can like solve this problem, or we're gonna spend 4 hours and we didn't solve it, right? So let's just go with this idea. Is this the best idea? No, maybe it's not. Do we care? No, let's just solve it. Okay, guys? Are we clear?
Yes, boss. Yes.
Okay, so Mantilla said if stack exists, so that means it's not empty. We're gonna while the length of stack one. I think.
One.
Yeah, so that means we're gonna keep looping until the last element, right? So when we're looping, we're moving the element here. Is that true, guys? I think so. Then
continue.
So how we can move this element to here? We're gonna do stack one. Append, yes.
You can add like a temp variable. Okay, you're talking with not stack.
Is it like this?
No.
Stack two.
No.
I think it's the other way around. If stack one, your work. Stack one is the one you are popping.
Okay, so like this.
Stack two append. Stack two append. Stack one to pop. I think this is how. Yeah.
So like this.
I think so, yeah.
So I'm appending stack what I did pop from stack one. Is that correct?
Hello.
Yes. Yeah. Go ahead.
Correct.
Please, your length stack one is supposed to be equals to one. It's not supposed to be greater than one. It's supposed to be equals to one. Length.
No, I don't think so, because you want to get the last value there. So it cannot be equal. Cannot be equal to one.
It's supposed to be equals.
No, because we want to get the last value. If it is equals to one, then it's also going to get that value for us. But we want to
to get the last value if it's equal to one. That's correct.
Yeah.
So
it's supposed to be equal to one.
Okay, let's explain it to him. So, this is our stack. You with me? How much the length here? It's 3, right?
3, yes.
So it's gonna keep looping. That's good. But when it's loop, we're gonna lose one. This one. We're gonna lose.
length is
then the length is gonna become 2, right? 2. And when the length is 2, this gonna go here, right? Now the length is what? Is 1, right? And 1 is this is false, so the loop gonna stop. So because 1 is not greater than 1, right?
Yeah, I understand. It.
Yeah.
Thank you.
Yeah, no worry. So now we have this. We keep looping and appending this element that we pop. When we pop elements, it pops from here. Then we append it to this stack. Now, what we're gonna do?
You get out the while loop and you return the last popped element.
Yeah,
now you know
can
what
return.
element left in the stack. No, not if the inside the if condition.
Yeah,
the
return stack
after the
1 pop. Because now we have only one element. We know that, we are sure. Now we need to return this element. We're gonna pop, return it.
You need to make to count for the other, if the other stack is the one with all the element in it and stack 1 is the empty one. So you need to repeat this code, but for stack 2, not stack 1.
Yeah,
I think
that will be, it's gonna be a bit weird, right?
I think
because we need to do it in append too. Yes, someone said something. Go ahead.
Yeah, I was saying what we need to do is like we should create a variable that we store what we popped out from stack 1, and then we reassign stack 2. Since we copied everything from stack 1 to stack 2, we are assigning it back to stack 1 and initialize stack 2 to be an empty queue.
So you're saying we're gonna save this, what we pop in variable, then we put him here?
Yeah, like we're going to what we have in stack 2. First of all, we have to remove what is in stack 1 already because it's just a
okay, it's empty. When we pop last element, the stack 1 is empty.
So we'll just copy everything from stack 2 back to stack 1.
Like this, right? But there was another idea is like, why not next time we pop, we work with this stack instead of working with this?
You have to
something
alternate.
like it's going to bring more code, but I'm just looking at we initialize like we are just using the variable like assigning stack 2 to stack 1 and then we initializing stack 2 to be equal to an empty stack.
Yeah, maybe the easy way is to just copy this here. So this way we don't need to change the push. We don't need to keep changing this.
Yeah, just
you have to transfer.
So after the root, but how are we gonna do that?
Go to
done in the while loop, I think. The transfer. Yeah.
Oh yes. So wow, that's great. Okay. That's amazing. If we did it in a while loop like this, 3. Now imagine we can move these here puppets, and then in same time we're gonna append it at the end, and then we're gonna pop this, but that's gonna change the length.
No. So one of them at any given state, one of the queues only has one element in it and is operating as a stack, right? And then the other one is operating as the placeholder where you keep the stuff that isn't in the stack. I mean, that isn't necessarily in the stack order, but is in the queue order. Essentially all the other values, but they're in the correct order. What happens when you pop, right, is from the queue that only has one element, you'll do the pop, you return it, that's fine. But then you need to find the next thing that's going to be at the top of the stack. That's when you use the while loop with that greater than 1 value to ensure that you then take from the stack that has all the other values and then you place until there's only one value in that stack that you've been removing stuff from. Then that stack essentially becomes the top of the queue. So as you remove that 3 becomes, now that other stack now changes from being the one that holds the placeholders to it now becoming the stack representation, i.e. it's the queue with one element in order to reproduce the last in, last out. It's a juggling act. You have to alternate between the two queues when you pop to ensure that the state of having that one element at the beginning is essentially the last in, first out.
Okay, that's also gonna change the push, right?
Yes,
Yeah,
that's why
then
I'm
the
saying
push.
that's why I'm saying that we should just assign, for example, just write something like pop equals to stack one dot pop, right? And then we return pop instead. Then we'll now assign stack two to stack one, and then assign stack two to be equals to an empty queue. I don't know if you get what I'm saying.
So it shouldn't necessarily be empty. If it's empty, it messes it up. What you can do instead is you can swap the two variables, right? So stack one, instead of pointing to the old one, can then point to the one that's now the real state. And then the
If
other
you're
one can
worried
now
about
become stack
if you're
two.
worried about the push, you can always just check if the
which
two
one?
stacks empty. If the two stacks are empty, you can push at anyone. But if you have one who is not empty, you find out which one and you append to it. You push to it to the stack that is not empty.
Okay.
Do
this.
You can create also if you can create a variable before return and assign it the stack one pop value return.
Yes, go ahead.
Okay. And after that you copy the element of stack 2 in stack 1 and the return you will return the variable.
Wait, so we can
before return
so like a temporary variable?
Yes.
Okay, like temp equal stack 2
1. No, stack 1 dot pop. Stack 1 dot pop.
Stack 1 that's pop?
Yes.
But that's gonna save 3, right?
Yes. Is the value that we want to return.
Oh yeah, okay, so what I thought is like maybe we saved it. Okay, it doesn't make sense. Okay, yeah, I see.
Stack 1 dot pop.
And then return temp. And then
before return,
stack 1 equals stack 2. And then stack 2 is empty.
No.
Yes.
It's equals to an empty queue.
This not will work. Stack 2 accolade.
Stack 2 accolade.
No, not parentheses. Accolade.
What is accolade?
Empty list. Brackets, yes.
Oh, brackets.
No. Yes.
What?
2 points. Inside
Square
2
bracket.
points.
Square bracket? Like this?
Return. No, empty list.
Okay. What do I write, please? Sorry, I'm confused.
Square bracket.
Square brackets, like this.
Yeah. Yes.
Okay.
And
But
2 points.
This DQ is an object.
Inside 2 points. Yeah.
Okay, so this is like slicing.
Just one.
What does it do?
Colon.
One.
Just a colon.
Okay.
What does this do? I know it's slicing operator. This is copy everything here?
Copy the element. Yes.
From the end to the
element in stack 2 to the stack 1.
Exactly. All the elements
okay,
to the stack 1.
But why this one doesn't work like this?
This is like another variable name to stack 2.
Yeah,
if you make stack 2 equal to empty list, stack 1 also will be.
Oh, it's a reference.
Yeah,
because we want to make a another copy that doesn't stay connected to the. Okay, I get it. Yeah, that's good.
Stack 1 is different from stack 2.
And now we clear the stack 2.
Equal to empty if you want.
I want to say something
or this
something like this, like in the chat.
Yes,
I
let me see the chat.
This is conditional for this.
I don't know this will work or no, but I want to something like this.
Yeah,
I think this also
this
gonna
might
work, right? Because stack.
I think this will work. Because
Yes. I think
what we're
append
doing is we're checking if stack is empty
while
before we do the append.
I
So we
think
can
this
just
will
check if
save the time.
I think it will work, yes. But because we start with this,
just
let's
do
try
else
to
instead.
continue this idea. So stack 2, do we empty it with DQ like this? Or
Yes.
there is a way to empty it? How do we
Yeah,
empty
yeah.
this?
That's the way to like make it up.
Can you repeat?
It's okay that way. Let's use the queue and to give us an empty stack.
This one, like this. What do you think? Let's see. Stack, then return temp.
Sorry, which language were you showing us before the hard.empty? Is it Python?
Empty? I didn't hear you well.
Is the queue.
Dot empty. Dot
Is
empty.
the method
Okay.
in the queue.
This one,
Okay,
DQ.
Nice.
So we're gonna create another queue that's gonna be empty inside. Then we're gonna return. So this way we're gonna just avoid creating more if and while. Now we don't know if this is gonna work, but let's check it out. Before, let's see top. So top return the element on the top of the stack, which mean if I have 1, 2, 3, implementing stack using queue, when I'm gonna do top, it should give me 3.
Yeah.
Exactly.
We can do. What do we wait? Can we use again the same thing that we used there? Like this is.
We can return the element stack 1.
-1? Does it work -1?
-1 element. Yes. It will work.
Okay, so return
Exactly. -1 element, the one at the last.
stack 1, then -1.
-1.
Yes, -1.
You can
Yes.
check. You can check if the stack 1 is not empty. It's not null.
You
The
have to
length
check
maybe.
if-
Check it the length.
No. In the top.
If the stack is empty.
Before
one.
return, check if stack 1 is not empty.
Oh yeah. If self stack
1.
Yeah, stack 1.
Exactly. Stack 1.
Self dot stack 1.
Back. Sorry.
Yeah, in line 21.
This should be stack 1, not stack.
In the if self dot.
Sorry. I'm back again.
If self dot stack.
So where we were, if self stack 1 exists.
If you want to show us an error.
Wait, what error?
No, it was stuck, just stuck. No, stuck 1.
Okay, yeah, fix it.
Okay.
Yeah, and the other ones too. In our initialization, I noticed that we were using stack 1 instead of self.stack. We need to go and correct all of them and change all of them to self.stack1.
Yeah,
self.stack2.
self. Someone asked why we're using -1. Can someone answer that?
Yeah, that is the indexing. When we use -1, we get the last the last value of the array, or the last value of the in a particular list. Yeah. Just the same way when we use 0. You know, when you use 0, you get the first.
Exactly. You can use -1 or use the length of the stack -1.
Yeah.
Works like that as well.
So, Massive, please go to line 5 and 6 and make the same correction.
Line 6.
Line 5 and 6, yeah. Self.stack. Yeah.
Okay. Now to empty, we can do what? can check the length, right? We can just do like if length self stack 1 0,
Return true.
it will return true. Oh no, sorry, return. So return if this condition is true, then it's true.
Yes.
Exactly. That's the best approach. So it's
What
true when
if
it's
the
zero.
other stack
Let's run
has
it.
something in it?
Maybe there's a mistake somewhere. Invalid syntax. What's a DQ?
Importation. Your import is wrong. I think it's import collections or something. You actually checked it the other time.
Yeah, but like
collections,
maybe I can.
collections.dq.
Exactly. Collections.dq, yeah.
Oh, just like this?
No. What I'm saying is from the gigs for gigs. What they wrote there was import collections. Then they were using collection.dq.
Yeah,
in their code.
but there is a way to use just DQ without mentioning this.
From
So-
collection, you import the queue. From collection, import the queue.
From collection. Oh,
Import the queue.
okay.
Oh yes, from the collections
Hmm.
for the queue, exactly.
Yeah.
I think it's JavaScript that is correct, that is causing it.
Please work. What? Another one?
Are
Oh,
you sure it's not this
self.
dot stack one?
No,
This-
just
yeah,
this
self.
self
The
thing.
joy of working with Python, Monsif.
Wait, can you repeat?
Yes, because you keep missing the self.
What happened here?
Runtime error. Index.
Not slice. Index must be integer. Yo, what did you say, Manitala? I didn't hear you. Manitala?
You use string, this string.
So I was thinking it should be 0 to -1. That's what I'm thinking.
0.
0
to
there, then
-1.
-1 the other side. I don't know.
Wait, what if we did just this? Oh yeah, we said that the reference it's not gonna work, right? Yeah, because we should create new one. So
check the output.
0 minus
What
1.
does the output say?
Stack 2 is string.
No, I don't think so. It's not string.
You know why I think this is failing? I think DQ is an object, so you
Yeah.
can't do
Yeah, how we
slicing on
can?
an object.
Yeah, let's ask how we can copy DQ1 to DQ2 without clone it. I forget that term. Extend. Okay, to have extend. So DQ extend. Yeah, is this a refer? Python not create new copy of another object, rather they create new reference to the same object. Therefore, it's my. So they're gonna be equal each other. If I use extend, is it gonna be a reference? No, using extend method will create a new copy. Okay, so that's something we want. So we can use d2 equal, okay, extend. So
I think you still have to have small further because we don't need the last index for that stack.
but we remove that index because we pop it, right? We didn't transfer it to the 2.
Okay.
Let's see if this can work. Something here. So it should be 2. It give us 1. What operation is this? This is pop. Pop. Let's see why it didn't work. We return 1. Okay, let's go through this example again. We do pop if self stack, which is this one. So we did push 1, 2, right? So self stack is not empty, it have 2. Then while len of self stack, which in this case gonna be 2, 2 is greater than 1, it's gonna go to stack 2, it's gonna append the pop. Oh, maybe pop left. Pop.
If you want to print anything, you can, and you can see output in bottom.
Yeah, maybe we should print something because it's good, accepted, nice. So the mistake was pop instead of pop left. So pop. So what happened is it was 3, right? And pop, it popped this one. And pop left, it popped this one.
Exactly. It was behaving like a queue. Exactly.
Yeah, but we don't want to do that. We want to force it like to use the 2Q. Okay, congratulations everyone. Now
this was supposed to be easy.
Yeah, it was.
Congratulations, Musib.
Try some.
I think it's easy. It's just hard because we are like all together trying to lead solution.
Exactly.
So everyone given his idea, which is
try submit كده Python.
Yes.
I actually like Shaza Ali's method. I love it. That method was okay for me.
So I think all the solutions are good. It's good like to discuss solution because we can learn different perspective. But like when we're gonna test something, we should choose one solution and do it.
Another I'd like to just say, what if we are not using DQ?
Okay, that's
if we are only using 2 lists.
That's faster, not slower.
85%. That's a good thing.
Yeah. For Python, it's good.
Yeah, so like we guys are 85%.
This codes are 22. If you use the C, I'm sure you will have maybe 100 lines of 150.
Yeah. Okay. Who doesn't understand something in this code? We can explain it. I guess everyone understand it. I posted in chat if you want like take a look. Let me post the code too. If you wanna like take it Python, then this. Okay. What do we end the session here? I think it's more than 2 hours. We can end it here. But maybe we can keep going and do tell me.
It's time to bed, bro.
Time to go to bed? Okay. Let's go to the bed, I guess. Okay, thank you everyone for being here. It was fun session. Let's see next week. And next week we're gonna see what?
Thank you guys.
We're gonna see the tree, graph, and heap and tree. Let's see them together. Okay, good night. Good night everyone.
If you
Good night, bye. See you.
If you want to try